So welcome, this is Greg Wagner with the 7th in our multi-part series on Java programming. And so today's class is going to go over classes, or lesson is going to go over classes. Classes are basically ways of representing kind of groups of data. It's kind of the basis for object-oriented programming, which Java is one of the languages that does that. So today's learning objectives are going to be understand what the attributes and methods are, know what the different class permissions are, be able to generate constructors, getters, and setters. These are basic methods in typical classes. And be able to link together classes, so basically be able to bring classes into other parts of your program. So kind of as a broad general definition, what is a class? And so a class is a programming term for a data structure that can contain both variables, which we call attributes, and methods. So basically it's a way to encapsulate kind of related data into a group. And then these kind of templates are a particular data structure that's used in object-oriented programming. So the term object means basically any type of kind of data that you can be generating, so be a function, a variable. And object-oriented programming basically focuses on the actual data instead of focusing on functions, which is functional programming, so or procedure-oriented programming. So procedure-oriented programming is usually considered like C, the C programming language, where Java, C++, Python are object-oriented programming languages where you're focused on kind of manipulating the data between different parts. And so to build an object, you usually use classes. And so all object-oriented programming languages, which Java is one of, has classes in it. So I'll demonstrate how you build a class in Java, but I kind of just first want to go to the terminology. So within a class, there are attributes. And attributes are basically the data, the variables you're storing within a class. And so if you're familiar with C, the items of a structure are considered variable, or would be a term of an attribute. And variables or classes are basically what you modify as part of a class. And then you use what we call methods, which I'll talk about in the next slide, as a way to modify these variables. So basically the class is built around kind of storing groups of data together. Think of it as like storing together, like, you know, your address. You have your street number, the street name, the city, and the zip code. And those would be kind of grouped together within what it calls a class. And then, well, I'll call the variables within a class attributes. Sometimes they're also called properties or fields, and sometimes the terminology is a little interchangeable. Sometimes some people don't, but I tend to call them attributes. I might slip up and call them properties every now and then, but it kind of depends. I'll try to keep it consistent. But basically, an attribute is a variable within a class. And then classes are built around, again, modifying these attributes. So to modify these attributes, here's the next thing. So you can also add into classes, you have classes, you have attributes and classes, then you have methods, which are functions that basically modify the attributes in a class. That's their main job. And so generally, the methods are designed to store, retrieve, and modify classes' attributes. And so basically, you're building functions within classes to modify your class attributes. And there's some exceptions for this. Generally, there's functions, they're called static functions that just kind of change things. So think of, in your first programs you made, you have the main function, which generally doesn't modify any of the attributes. It basically just runs as a driver or a wrapper. And so within classes, we have permissions, and I'll show this when I do the demo here in a few seconds. But basically, each object within a class, so the attributes and methods, you can label as private, protected, or public. So private objects can only be directly accessed by the class itself. And generally, the private by if you don't put private in front of a class attribute or method, it'll be private by default. And they kind of just do to protect this. So basically, the permissions are so you allow other users of your classes to only have access to certain things you want them to modify. And so generally, private objects are the attributes themselves, and you want those to not be directly accessible, mainly for debugging reasons. And then methods within the attributes that kind of just modify stuff within your class. So protected objects are very similar to private objects, except we'll talk about inheritance in the next lesson, but protected objects act as private, but if you have an inherited or a child class, so a class that can access the attributes of the parent class or another class, it can access the protected methods and attributes as well as the public ones. And then a public method is a method that, or attribute, is one that can be accessed by anyone outside of the class. So I'll show what these mean later, but basically the idea is you can have different layers of protection for certain values within a class. And then basically within a class you have a set of methods. There's basically three sets of methods, types of methods that you have within a class. And just kind of give you the terms so when I talk about them, you have a constructor. So a constructor, basically its idea is to initialize all the values within a class, and what it does is it instantiates, which means creates the class object for other uses. So it will basically allocate the memory for the different variables. Then you also have getters and setters. These are also called accessors. They basically allow you to get access. You get what means retrieve the value of an attribute, or set means you store the value of an attribute for the getters and setters. Like I said on the previous, or on the attributes. On the previous slide, I said generally you make attributes private. The getters and setters are going to be public methods that you can get different values. And then you have a mutator, which basically modifies the different values of your classes. So what I'm going to do now is kind of just give you a quick demo of how to build a kind of a basic class. Okay, to give you a demo of what I'll be making for how to make classes and stuff like that, we've already done a little bit with the previous things, but what I want to do is basically create a new package, and we'll talk a little bit more packages, how they relate to importing and importing stuff later, but I'll make a new package. I'm going to call this classes lesson 7, and this will be uploaded onto GitHub. And then, so within this class, I'm going to make a new class, and this basically what I'll be demonstrating is, like, since I do a sports site, we'll do sports stuff. So we'll call this class scoreboard, and build it. And so for classes, I might have said this before, but classes need to have this class name needs to match the file name. So in this case, scoreboard.java has the class scoreboard. And so we're going to, like I said before, we're going to have basically attributes, methods, and we'll build these up. So the first scoreboard, we'll basically have 4 items. We're going to have a private integer home score, private integer visitor score, and then we'll do private string home team name and private string visitor team name. So basically I have 2 teams competing against each other, and this is the attributes. So notice here we have the permission, so private, so these attributes can only be collected in this program, or it can be accessed within this class directly. And then we have the type, and then the variable name. And then so I'm going to start making some methods. And so I'm going to make, what I'll do is overload a constructor. So I'll have 2 constructors. So first off, I'm going to make my constructor public, so it can be accessed outside of the class. And I'll call this scoreboard. And this is going to have, basically, I'm going to initialize it with all the values. So I'll have int home score, int visitor score, string, home team name, and go to the next line, string, visitor team name, and I'll set these up. So I'm going to build this as basically as a basic function, and then notice here, once I get this set up, that my constructor name is basically, the function name is basically the same as the class. So within here, I'm going to assign the values. So if I want to access an attribute, or any item within a class, I use the this keyword. So I do this dot home score equals home score. So we have the local passed in parameter here, and I didn't mention this before, but if you pass in a variable name, it has a higher precedent than the class attribute name. So if you pass this in, this will be assumed to be the passed in value, and I'm assigning it to the class's attribute. And so if I do this dot, it will basically be the internal name of whatever your attributes is. So if I do this dot visitor score, it will store it into this location, hence the name this. So do this dot visitor score equals visitor score. So again, what this is doing is it's taking the value that we've passed in and assign it to this value, or assign it to this class. This dot home team name equals home team name, and this dot visitor team name equals visitor team name. And so for all intents and purposes, visitor team, I should change this to visitor team name so it lines up. And notice how parameters, to help you out, Eclipse says parameters does this kind of light brown color, and then attribute values are blue. So I've made a basic constructor, and also I want to make an empty constructor. So a constructor that basically assigns generic values. So I'm going to do public score. So instead of actually typing it out, Eclipse has built into it, if you right click on a space in a file and hit source, if you go down to the middle here, you can see constructor using fields. So Eclipse calls the attributes fields, and so that's kind of, you might see me change that up. So we already have one that does all these values, so I'm going to take this out, get rid of all of them, and I'll change this to put it after last member. So it calls the last member, so it calls any object in here a member. I'll put this value here. And so what this does is it basically doesn't assign any values. So to kind of fix this, I'm going to initialize the values in here to 0. So what this happens is if you instantiate a class and you don't assign the value in the constructor, it will assign these values. So what the scoreboard will do when it runs is it'll put the home scores as zeros and the names as an empty string. And then you see this here. What super does is if there was a super class to scoreboard, and we'll talk about inheritance later, it would instantiate that super class using super. Super refers to the parent class or the super class. So we have the basic methods, and so I'll label this constructors. And then I'm going to make some getters and setters, are also called, in the textbook I have linked, they're called accessors. And so say I want to, so to get values, so I'm going to do public. Again, I'm making this accessible anyway. So I'm going to do the return value. I'm going to do a getter for home score. So I'm going to do return value of this. So it's going to be int. I'll say get home score. There's going to be no parameters passed in. And all I'm going to do is return this dot home score. You can also notice if I just do home score, since there's no parameters to take over it, it will still have pass this value. Again, you can tell that it's the value used because it's the class attribute because it's blue. But I like using this whenever I'm assigning the value. It makes it a little bit easier for me to kind of understand it. So this is a getter. So notice I get the value. And you don't have to call them get. You can call them whatever you want. And so I'm going to make a setter. And so the return value, there's not returning anything, just reading in the value. Set home score. And so, like I was saying before, these are called getters and setters because you don't have to do them this way, but it's kind of been a best practice. Whenever you accessors, you always call them get and set. So I'm going to say set home score. I'm going to pass an integer, calling it home score. So here, what I need to do is I'm going to do this, the home score equals home score. You'll see here this gets blue matching with this, and this being brown to match the parameter. So you can generate getters and setters also using right-clicking on the window and hitting source, and say generate getters and setters. And so I'll do home team name, visitor score, visitor team name. And this will generate the getters and setters for all the other functions. And notice here, it has the return value of int, void, and stuff like that. And then basically, we don't really need it for this class, but since I talked about mutators, for a mutator, an example would be, say if I want to increment the score, it would just basically modify the value. So do public void inc home score, and then not pass any parameters, and then this dot home score plus plus. This would be an example of a mutator where it just modifies a particular value, and you can make these public or private. Generally, almost always getters and setters are going to be public, but sometimes you have mutators that are doing internal functions, and those might be private. Generally, you'd make it a private method be something that just is a helper within your class. So maybe you have a larger method that you're trying to modify. So change this to visitor, and this is our basic class. And then finally, I just want to talk about using packages. Now, packages are used together to group together types of classes, and usually basically packages are used to kind of group together different types of classes together, and then you can import or basically tell another class that's not within that package, hey, this is how you use these classes. And you've seen the import function before, or the import command before, and then you can see how how basically allows you to have access to different things. So I'll show you in this upcoming demo how to put stuff packages and then how to pass them to other stuff. Now, to kind of go into making packages, so you see up here I already have package lesson 7, and I'm actually going to make this a sub package. So I'll make this, I'll call this class lessons, and I'll call this scoreboard. And then I'll see an error here, and then so I need to basically move this from this package to this other package. So what I'll do is I need to make a new package. I'll call this new package, and I'll call this classes lesson 7 dot scoreboard, and finish this. And so I have a scoreboard within this class, and I'm going to drag and push this in here. Update all this stuff, and I don't think it'll change anything. And then notice how this is fixed. So within classes lesson 7, I have .scoreboard, I have a scoreboard in here. And so what I'm also going to make, I'll have to actually make another class. So I'll do new package classes lesson 7. We're going to erase this. We'll erase it. Let me refresh this. Oh, it'll pop up when I'm going to make a new class. And so the package I'm going to put in is classes lesson 7. I'll call this just seems to be lagging for a second. Let me try this again. Let's make a new class. Put this in classes lesson 7. Classes lesson 7. And then I'll make this a main, so this will have a main function. So notice here it creates another class. And for in the main, so I'm going to bring in some import classes lesson 7 .scoreboard, and I'll actually get the scoreboard class. If you put the star, it'll bring in all the different classes within a package, but I like to put them individually. It saves a little bit of memory and makes it easier kind of to see what we have going on, at least for me. So first I'm going to instantiate a scoreboard. I'm going to do it two ways. One way is going to be an empty class. So this way, if I just do if I do new, so new allocates memory, score board, and then I have an empty value, you'll get a class that basically has nothing in it when it gets instantiated. And so for this one I can do scoreboard, I'll say set home team name. I'll do, it's my favorite football team's the Chiefs, so I'll do Chiefs. And then the scoreboard dot set home score. We'll do 35 for the number of points. I'll do scoreboard set visitor team name. We'll do the Chiefs rivals, which are the Raiders. And then we'll do scoreboard. Shoot, I need changes to set. And do set visitor score, and we'll say the Chiefs beat the Raiders, so we'll do 14. And we have basically a fully rectified scoreboard. And so if I want to say modify the points, we do scoreboard and say the Raiders scored an extra point. I can do increment biz score, and this will increase the points by 1. And if I want to do a full constructor, use a full constructor, I can do scoreboard. I'll call this scoreboard 2 equals new scoreboard, and we'll do the teams will be so we'll do the visitors. So I need to look at this. The first one is home score, so we'll do 14, 17, and then we'll do other set of rivals. We'll do the Dallas Cowboys and the Philadelphia Eagles. And so what this will do is these two values will be the home score, visitor score, home team name, visitor team name, and they'll be set initially into scoreboard 2, and then we can modify these values as we go. And so notice here we brought in, imported a value, so I basically built another class, and what classes are, there'll be folders within your source document, but in Eclipse you can just right click on something, do new, and then build a new package. We get the package values. So this is in this particular package, but notice here we have the package classes lesson 7 dot scoreboard, and then if I make other files, which I'll do in later documents, later lessons, we can package in multiple classes into this. So I hope this video helped you out, and the next one will go over polymorphism and inheritance.